Hello everyone, hope you all are doing great. Welcome to Tinkerly Science session, and this is the demo session for practical science of electricity. This is what we'll be studying in this particular session. We'll be covering the topics which are already mapped with your curriculum of your electricity chapter, okay? And we'll be also visiting a virtual laboratory for more experiential learning, and which is provided by PhD simulations. Okay, the person that you are seeing on your screen is Thomas Edison. He's the one who invented the bulb, and this bulb is the first bulb that was invented. And just like bulb, all the other appliances like AC, cooler, fridge that we use in our day-to-day life, they all are powered by the electricity. So now the question comes, how does the electricity flows and electricity is supplied to those appliances, right? So let's discuss about that. What is electricity and what are charges? Okay, there are two types of electricity, dynamic electricity and static electricity. So as you can understand from the terms, dynamic means flowing, it's not still, and static means it's still. For example, I'll give you an example of static electricity. So in winter, sometimes when you touch metal by accident, you feel kind of zapped, electrical shock, right? It happens because of the static electricity. Okay, so we won't talk about that static electricity in this particular session, but in further session we'll be talking about that kind of electricity. But in this section, we'll be only talking about the dynamic electricity. So what is dynamic electricity? It's a flow of electrical charges, right? So what are electrical charges? So let's talk about them. There are two types of electrical charges, positive charge and negative charge. You are seeing a monkey on your screen, okay? And if you zoom into it, you'll find that this monkey is made up of so many organs, like heart, lungs, kidney, and all of these kind of organs. Okay, so if you zoom into those organs, you'll find that those organs are again made up of cells, and those cells are again made up of many things like mitochondria, DNA, RNA, nucleus, Golgi bodies, right? And if you again zoom into that cell, you will find that all of the things are made up of atoms. Atoms are the smallest unit, right? So atoms are again made up of three things, proton, electrons, and neutrons. And here comes the phenomena of positive and negative charge, right? So if you take two protons, they will repel each other. If you take two electrons, they will again repel each other. But if you take one proton and one electron, they will start attracting each other. Why this? Why does this happen? It's the similar case as we see in magnets, right? The same poles of the magnet repel each other, but the different poles of the magnet, they attract each other. The same thing happens here with the charges also. Same charge repel each other and opposite charge attract each other. So we can say that the protons and neutrons, they have opposite charges. So it has been said that the protons have the positive charge and electrons have the negative charge, right? And the neutrons on the other side, they have zero charge. That means they are neither positively charged nor negatively charged, right? They are neutral. So it's not like all of them, they have the same size. Protons and neutrons are bigger than electrons. And the reason why when we talk about electrical flow, we only talk about the flowing of electrons. Only electrons can flow because they have the smallest size. Right, so only negative charge can flow, but the positive charge, which are protons, they cannot flow because of their bigger size. Right, so all the atoms, they have different properties. and they have different properties because they have the different number of electrons and protons. For example, carbon has 6 electrons and 6 protons. So here comes the phenomena of conductors and insulators. As I have told you that all the atoms have different properties because they have different number of different number of electrons and protons, and because of those different properties we can divide the materials into conductors and insulators. So in conductors, current can flow easily because they have the free electrons present inside them. But in insulators, electrons cannot flow because they are tightly bound, and that is why insulators cannot conduct the electricity. A nearest example of insulators and conductors is the wire that we see in our daily life. The inside part of that wire is made up of metal, and that metal could be iron or copper. And we cover that metal with a insulator, which is generally made up of plastic, right? So this is the basic example of insulator and conductor. Now the question comes, how do we connect these wires to the electrical appliances and the resource of electricity, and all those appliances get powered by the electricity, right? So for that, here comes the phenomena of circuit, right? So for example, I have two materials here. One material is positively charged and other material is negatively charged. Okay, and they have charge imbalance because the negatively charged has more number of electrons as compared to the positively charged. Okay, so to balance the charge, if we connect those two materials with a wire, the electron will start flowing from the negatively charged to the positively charged, right? So you can compare those electrons with marbles. So if you put some marbles on higher place, all the marbles will come rolling down to the lower height, right? So the same thing happens here with electron also. All the electrons will come flowing to the positively charged from the negatively charged, right? So in this case, the positively charged has less number of electrons and the negatively charged has the more number of electrons. And electrons will flow from negative to positive, right? So if you replace those positive and negative materials from the battery, the positive terminal of the battery will always want to gain electrons because it has a less number of electrons as compared to the negative terminal of the battery, and that is why the flow of electrons is always from negative terminal of the battery to the positive terminal of the battery. Okay, so this is not exactly the flow of electrons, it's the flow of electrical energy. So electron transfer its energy to the next electron, and that electron transfers its energy to the next electron to it. Okay, and whenever we talk about the flow of electrons, we are talking about the flow of electrical energy, right? So what is circuit? If you connect the negative terminal of the battery to the positive terminal of the battery, we provide a path for electrons to flow, and on that path the current will flow, right? So this is the basic example of the circuit, right? So what will happen if we break the circuit? The current will stop flowing, right? And if we connect a home appliance to that circuit, it will get powered with that electricity, right? So in this case, the bulb will start glowing if we connect that bulb to the battery, right? The circuit that you are seeing on your screen is the most simplified circuit that we use for to power our home appliances. The transformer provides the electricity to our houses, and when we turn on the switch, all the appliances get the electricity and they turned on, right? So for example, the bulb, this is how the bulb glows. The transformer supplies the electricity to our houses, and when the main switch is on, the electricity flows to our switchboards, and when we turn on the switchboard, the electricity again flows to the bulb and the bulb starts glowing, right? So this is the basic example of the circuit. Do you know why we should never connect a battery like this? Like this wire is directly connected from the negative terminal of the battery to the positive terminal of the battery. So if you connect the battery like this, the electrons will directly flow to the positive terminal of the battery, and the wire will heat up very fast. And because of that heating, it can catch fire very easily, and we call it short circuit, right? So in this circuit, we should always have some resistance so that the electrons cannot flow from the negative terminal of the battery to the positive terminal of the battery. Let's move to the virtual lab now. So here is the virtual lab of our PFET simulations. Okay, so in this lab we'll learn about circuit elements, circuit connections, and conductors and insulators. So as you can see on your left side of the screen, here are some circuit elements. Here is the wire, this is the battery, it's a light bulb, it's the resistor, and here is the switch. So using all of these elements, we can make our own circuit. So I'm making my circuit here. Here is the battery, okay, and I'm connecting that battery to the wire like this, okay. Now I'll use another wire, okay, like this, and I'll make it vertical, okay, and I'll connect this wire to the bulb, okay. So I can use another wire to connect another terminal of this bulb, and I can make it a little longer like this, okay. We'll use the resistor in our another circuit, but first let's make a basic circuit, okay. Here is another wire, and now let me use the switch, okay. Here is I have connected the switch, okay. So now let's just connect this switch and the wire together like this, okay. So all of the elements are connected, right? Now to supply the electricity, I need to turn on the switch, okay. So let's turn on the switch. So as you can see that the bulb starts glowing, okay, right? So if you turn off the switch again, the electricity stops and the bulb stops glowing, right? So what will happen if I connect a resistor to it? By the way, what does a resistor do? As I have told you, it will make some resistance in the path of electricity where the electricity is flowing, so that from the positive terminal of the battery, from the negative terminal of the battery, electrons cannot directly flow to the positive terminal of the battery to stop it from short circuiting, okay. So now I have added the resistor to it, and if I turn on the switch, you see that the bulb is glowing, but the electrons are moving at a slower speed, and that is happening because of the resistor which is present in this circuit, right? And the bulb is also glowing with less glowness, right? It is happening because less current is flowing to the circuit because of the resistor. And now if I turn off the switch again, the electricity will stop glowing, okay. So I'll just delete this resistor from this circuit, and I'll use other circuit elements. Like I have um, different types of things here. for example, a coin, eraser, paper clip, door. So I'll add all those things one by one. So first I'll add this dollar bill, and let's see whether it can conduct the electricity or not. Okay, so let's turn on the switch, and as you can see that this this currency note, which is made up of paper, is insulator, and the insulator do not conduct the electricity. Okay, so let's remove it from the circuit and use another thing. I have a paper clip here, and you know that the paper clip is made up of metal, right? And as you can see, the circuit again starts, the current starts flowing in the circuit again, right? Like this. Okay, so if I turn off the switch and I remove this paper clip from the circuit and use another thing, and this time I am connecting this coin to the circuit, and let's see if it can conduct the electricity or not. So I have connected it to the circuit, and I'm turning on the switch, and as you can see that the current is flowing, and it is happening because the coin is made up of metal, right? And metal will always conduct the electricity. Okay, now use another example. I have an eraser, and erasers are made up of rubbers. Okay, and rubbers are insulator, so if I turn on the switch it won't flow the current because it's insulator. And as you can see that the current is not flowing. And now I'm using another material, which is a pencil. Okay, and if I connect this pencil to the circuit, let's see what happens. Okay, so if I turn on the switch, so as you can see that the current flows. But why is it flowing? It happening because the pencil has the graphite, and the graphite is non-metal. But there are some non-metals, and graphite is also exceptional non-metal which can flow the electricity, which is conductor. Not all the non-metals can conduct the electricity, but there is graphite which can conduct the electricity, and that is why the current is flowing through the graphite. Okay, so let me connect this dog to the circuit, but the current will not flow because this will have a lot of resistance to it. Okay, as you can see the switch is turned on and electricity is not flowing. It's not flowing because the body of that dog has more resistance, right? And because of that resistance the electricity won't flow. Okay, so there are other stuff that you can use in this um, virtual laboratory. So here is another battery. What will happen if I use another cell? The bulb start glowing more, right? So here I am connecting another cell. Okay, this is how I'm connecting this cell to it. Okay, as you can see the bulb start glowing with so much brightness, right? It is happening because we have increased the voltage in this circuit, right? But if I connect that battery from opposite terminals that I have used previously, like this, okay, and switch is turned on, okay, but as you can see that the current is not flowing. So to flow the current we should always connect the negative terminal of the battery to the positive terminal of the battery. If the negative terminal of the battery is connected to the negative terminal of the battery, the electrical current will not flow. It's because the electrons will repel each other and they will not get attracted by any positive terminal. Okay, and electricity will not flow. Again, just electricity will start to flow. Okay, let's connect another battery to this circuit and let's see what happens. Okay, here is the battery, and I'll reverse the terminals again. and connect the positive terminal to the negative terminal of the battery like this, and let's see with how much brightness the bulb will glow. As you can see, the brightness again increased. It happens because I have increased the number of batteries, right? So you can use this PHT simulations for doing more stuff, like you can use a human hand and see whether it gets current or not, and many other stuff you can do using this particular PHT simulations. Okay, so that's all for today's session, right? So thanks everyone. If you have enjoyed the session, you can be the part of more sessions on electricity, and we'll be studying in the same manner about this about the electricity. Okay, so thanks.